Well, hi, good morning, and thank you so much for joining me here in my shop. And I have to start off with a warning. The warning is there are two troublemaker kittens here. They are following me all over the place, and wherever I go, they like to go. And then they cause trouble. Look at them. They're looking for trouble. Yeah. But they won't do the laundry. I talked to them about that. They just will not take care of it. So, what I want to do today is change out a couple of capacitors, maybe 3 or 4 altogether. These two here, get rid of that stuff. And also the capacitor that's responsible for protecting the output tube grid. That's really my target today. Plus I want to get familiar with the schematic a little bit and see if there's any tricky stuff. Wow, there's a very fancy capacitor here with a silver cap, it says on it, something like that. I'll show you that. Can't say I've seen one that looked like that. Sickles, silver cap, Sickles. Oh, couldn't have come up with a better, like, really, that must have been the guy's last name. Bob Sickles. Silver cap. What is it about? I've never seen one of these. Is this a junk box thing? Some previous repairer? It's got a yellow shrink tube on it. Any of that anywhere else? That's a yellow wire. No, I don't see any other shrink tube in here. Well, that might be a replacement. Wow, the guy spent his Sickles silver cap on this radio. Wow, I would have put that in my forever collection. I don't have a forever collection of capacitors. Okay, great. Well, we're going to study this schematic and make a few observations too that are important in terms of working on the radio safely and knowing what's going on when stuff starts going on and all that. Okay, let's look at that schematic. Okay, here's the schematic. I downloaded this from Radio Museum, and let's just zoom in a little bit on it. So, power supply. Let's take a look at the power supply situation. So this has got Lochtel tubes in it, including a rectifier. This 35Z3 is a Lochtel tube, and you see there's no center tap in the heater, so there's no cheap and easy way to get 6 volts to run a light. So what they've done is they have another cheap and easy way. They've got a resistor here, and the light is across the resistor. So this is dropping just the right amount of voltage to drive the light. This would be a voltage divider circuit, and this is why, like in this radio right now, the light is burned out. So this resistance through here is no longer 40 ohms in parallel with the light, and I don't know what the resistance of a light bulb is offhand. Probably something similar. With that gone, then we really have a slightly raised resistance here, maybe from 40 to, I don't know. No, it wouldn't be from 40, would it? It would be from these two guys in parallel, so maybe 30 up to 40. That doesn't seem like much, does it? Because there's an 80 right here. So this 80 just must be throwing away some energy. And this would be 35, 85, and then 36, 6 and 6, 24, and then 24. Do it again here. 85 and 24. Wow. 85 and 24 is 110. Huh. Okay. Well, sometimes it's 110 in the outlet, so these would be running under voltage a little bit. Okay, anyway, I'm not going to change any of that, so I think we should probably find a light bulb, stick it in here. And what kind of light bulb is that? Did they note it on here? I'll have to look somewhere, but it's almost certainly a 47, but it could be something else. I think a 47, I think, is a 1/4 amp bulb. I'm not sure of that. So, look at, so that's interesting. I hadn't realized that. There's a field coil. Oh yeah, I'm looking at the speaker. There's a field coil in the speaker. So that's why this radio is not humming. And these filter capacitors, look at this, 20, they're small compared to many other radios because of this powerful filtering action of the inductor here. So 1, 2, 3 fairly small ones. It shows here 100 volts here. That's not very much. Usually it's a little higher than that. But I guess, would it be the case that, well, you're dropping some of it right here, right away from the radio. Okay, 100 volts, that's fine. So anything else we need to look at? Yeah, we need to look at how the chassis is connected. So we'll follow a B minus line out of here. That would be this line here. Okay. That's right here. This is probably the AVC line here. Yep. AVC line. That's probably the AVC capacitor there. And keep following the B minus. And we have a very small capacitor to, this is the chassis connection here. We have a large capacitor, 0.2, with a coil around it, which we saw yesterday, going down to the chassis. So interesting arrangement here that they have two capacitors of dramatically different sizes here. Not sure why they would do that. Like this big one here must have something to do with the coil and capacitor effect here, which I believe are resonant at the IF frequency. I'm not sure though. I'm not sure what they're doing. This is a minor improvement in the operation of the radio. I believe in many cases people will just change this with a 0.2 capacitor, drop the coil. I don't know. I'll probably leave the one that's in the radio, just leave it there. Okay, so we see B minus isolated away from the chassis except through these capacitors. We'll continue along. B minus. So doing way up here. Ground to chassis for loop operation. Well, that has to do with the antenna arrangement. I think that's 1 meg, not 0.1, 1 meg. The switch here. So I believe what they're doing is this is quite the radio. On a short wave, they're kicking in this stage of RF amplification. But on a broadcast, the grid is getting its signal, I guess, from out here through all these switches and stuff. Lots of switches here. So no doubt these switches are related to switching the antennas around when you're going from broadcast to shortwave. That would be my guess. Look at all these coils in here. Wow, master coil. Now here's something interesting too. We saw this in the radio yesterday when I was showing where wire was wrapped around another wire. This is it right here. In this case it's showing 3.5 picofarad connection. Could you connect this directly with a 3.5 picofarad capacitor? I think so. I don't think you need to rely on this technique. I'm not absolutely sure why they do this and not use a capacitor. Cheap. Some kind of special isolation? I don't know. I don't know. It's just a weird form of capacitor here. Should not disturb this. Now, the antenna. Well, the sad thing is the antenna is missing. Now, this really throws everything off completely. Well, that's why there's multiple wires sticking out the back of the radio. And this is very common in these old radios. The back is gone and the antenna is gone with it. How you overcome that? Wow, that's a toughie. This is almost certainly designed and tuned to resonate around the broadcast band and help pump up the radio on the broadcast band and then shoot the pumped up signal over here. Without this loop, there's no pumping up of the signal. It's going to be much lower if you use a piece of wire or something. Now when I hook it up to an antenna here in my shop, I'm hooking it up to a powered antenna. It's even better than this loop. So probably the radio in my shop will work great. But unless you stick a really good source antenna on it, without that loop. Shortwave, on the other hand, is a totally different deal. Let's see if we can figure out. So the shortwave must be energizing this tube. So it must be coming in here. It's got this these coils here. And then we're off. So what position is the switch in right now? Switch is shown from rear in broadcast position. Shown from rear in broadcast position. So that means we should have a hard time getting to the antenna terminal. Through here, we should encounter an open switch. One doesn't look open. Okay, well, that's because well, maybe I'm wrong. Maybe the broadcast does go through here. Then what is this switch for? It's so in one case you're coming through this tuned transformer. I shouldn't call it tuned. You're coming through this transformer. In the other case, you're bypassing. What are you doing here? They're definitely bypassing this. So maybe what they're doing, they don't care if the signal's here all the time. It doesn't matter to them. It doesn't matter to the radio, to them. Them, those people. Okay, enough studying this now. I'm not going to gain any more advantage from it. We need to go look at the other end of the radio now. So sometimes it's good to just, at this point, it's okay if all you get in your head is that there's something you need to pay attention to later. You become aware of something, but you don't need to understand it at this point. You just put it on the shelf. I'll understand that later, if I have to. So I can't, trying to figure everything out right at the start here is probably folly. So the output tube grid is receiving its signal through this capacitor. Now look at the plate voltage on this side, 35 volts. Wow, that's like the lowest. Usually this is 60, 70, 80 volts on the plate of a detector. And I'm not sure why this is, that it's so low, but I think it has something to do with noise. That if you operate these guys in a less appropriate way, you get a lot more noise. I think. I'm not sure of this. I'd have to read up. And so by using the low voltage, the electrons are not accelerated as quickly, and they don't strike the plate with as much energy, and they don't bounce off and bounce back on it and make that kind of noise. Am I right about this? I don't know. But that's really low, 35. So this capacitor's job is to keep the 35 volts on the left and not let any of it show up on the right. So this circuit here is high impedance. It's 500,000 ohms sitting here. So it wouldn't take much charge to leak through over here and pressure this up. And what will happen is the grid will be pushed more and more positive. That's bad. That's bad. You want the grid to always be negative with respect to the cathode. So what are they doing with the cathode? So we follow that down here. What is going on out there with my cats? They wrestle a lot. There they go. Okay, back to this. So we come down here, we find what's called a cathode resistor, 180 ohms. That's typical. These things are usually somewhere between 100 and 300 ohms, somewhere in that range. There's current flowing through the tube all the time when it's operating, and that current will cause a voltage drop here, and that voltage drop will result in the cathode being positive, being lifted towards the plate. You can even think of it that way if you like. So some positive voltage here, probably 10, something like that, 10 volts, and that makes the cathode positive to the grid or the grid negative to the cathode, and presto, you've got your bias by pushing up the cathode. There's other advantages to doing this. There's other disadvantages to doing this. this technique to bias a tube, but it's very, very common on output tubes. The difficulty here is where do you get the negative voltage to bias this grid? If you wanted to leave the cathode and push the grid negative, where do you get that negative voltage from? The only place on the radio where there's a negative voltage is here at the detector. Or if they played tricks with the power supply, but they didn't play any tricks with the power supply. So there is a tricky way of the power supply to get a negative voltage relative to what's being used as B minus, and then you can direct bias this. But normally no. Cathode resistor. These resistors tend to go high and increase the bias on the tube, which will quiet it down. I don't think it'll hurt it. The opposite is also true, not here. I don't think resistors tend to go low, they tend to go high. What's opposite is this grid, which should be at B minus voltage or 0 volts, could be pushed positive because of a leak through here. And it can get positive to the point where the bias is gone. The result of that is a much heavier steady current through the tube, and you'll wear out the cathode quicker. And you lose grid headroom, so a signal coming in, if it's large enough, will drive the tube into cutoff or something else like that. And you get bad distortion. But you could have the bias of this tube compromised by a leak here and never know it. And unfortunately, in those conditions, the tube here is going to wear out quicker. It's wearing out quicker anyway. It's an output tube, it works hard, there's heavy current going through it, and it wears out its cathode prematurely compared to these other tubes, which are loafing along here having a party while this guy's working hard. The other guy's working hard is this one here. These are the two guys that tend to quit early. Okay. Boy, I talked myself. How long? I've been talking for ages here. So so we want to do these 3 capacitors here and this one today. Okay, we're going to start with these 3, that's for sure. Okay, so I'm going to wait for a little while. They're distracted by numerous things. So this guy and this guy both have their negatives tied to the same connection. What are you guys doing? Crazy in here. So that's good. And then we have this one, which looks like it might be a 20 according to the yellow color here. The other 2 have been cut off. This is a real junk box guy. 20, and it's going down to the output tube. I think it's going to the output tube. This is probably the bypass on the cathode resistor, and then this is probably, what's this supposed to be, 10 and a 40 on the yellow. What's it doing there? Shouldn't be a 40. So I have 2 22s and a 10. These are the correct sizes according to the schematic. I'm going to put them in. They all have a common negative. So what I'm going to do is I'm going to twist the negatives together on these 3. Put them here, and then I'm going to cut the lead wires off of here so I can utilize them. So I'm just going to cut them like this. And I'll cut these shorter later. And like that. Take these guys here, and the negative is the shorter one. Twist them all together. Should I twist them all together? A bit of a bundle. And be kind of sitting upright here. Sure. I think I can do that. Now let's do it one at a time here. Okay. Uh-oh, I can hear the TV. Let me close my door here. even that, I don't know if you could, I don't know if it got picked up, but if it did, even that little bit of music coming from the TV upstairs is enough to give me a copyright hit. So what I want to do is basically fold the positives up this way. And we're going to solder that in there, it'll become rigid. And then I'll connect these wires up to it. Okay, and get that done. Well, this is where that wire to nowhere was connected. It was connected to this terminal here. That must have been remnants of a past capacitor. That's probably what that was. Just wanted to mention that. I'll just turn on the camera for a minute, give an idea of what I'm doing. So I have the capacitors soldered into the B- terminal, and now I'm making the connections with the old wires. I try to make those connections as far up on the capacitor lead as I can, and I don't need to put in protective tubing or anything like that. As long as I can make it up nice and close to the capacitor. Maybe not so much this one. This one's got some propensity to hit the chassis here, but I don't think these capacitors are going to move any distance at all. Now the last wire, I can get rid of this black one here. This orange one. Uh-oh. Woo! Orange wire, not so long. Oh, shoot. I'm not going to make it. Okay, I need a new piece of wire, unfortunately. Okay, stop and do that. Okay, filter capacitors are in, and we need to test this radio. Make sure it still works. I have a technique, a skill where somehow I manage about half the time to get capacitors like that in backwards. I've been trying to improve my skill, so it doesn't happen so often, but goodness knows I've tried. Same thing with the diodes. Somehow, no matter how hard I try, I get them in backwards. Okay, so if this is in backwards, it's going to pop. It may pop. Okay, so switch is on, and power is... I'm just going to back up a little bit. Power is, so switch is on, power is on. I didn't put a light in. I should have put a light in already. We need the light. 110 volts on them. Hey, that's an interesting question. What is the voltage on those capacitors? Okay, it's humming. Doing something. Okay, now we want to read the B- across the capacitors. Volts DC. So we're going to negative, this gigantic overused terminal. This guy, 65 volts. This guy, 88 volts. And this last guy, 105 big volts there. This one here, yeah, I think that's correct. I hope that's correct. The reason I hesitated was I thought, well, wasn't these a bypass? No. There is no bypass. Cathode resistor bypass. There is none. is 3 filter capacitors. Good show. Okay, we got this one done. Now we're going to go after the capacitor that's the grid blocking capacitor. So first, which tube is the output tube in here? So this is a 35Z3. This is the rectifier. This must be the output tube here. In a different socket, 35L6. In the socket, it really doesn't go in very tight. So that's the output tube. So we're looking for a capacitor that ties onto one of the terminals of that tube. I don't see any, for crying out loud. Okay, we gotta find out which terminal it is. I'm gonna hunt down the capacitor here. Okay, filter capacitors are in, and we need to test this radio. Make sure it still works. I have a technique, a skill. I have a skill where somehow I manage about half the time to get capacitors like that in backwards. I've been trying to improve my skill, so it doesn't happen so often, but goodness knows I've tried. Same thing with the diodes. Somehow, no matter how hard I try, I get them in backwards. Okay, so if this is in backwards, it's going to pop. It may pop. Okay, so switch is on, and power is... I'm just going to back up a little bit. Power is, so switch is on, power is on. I didn't put a light in. I should have put a light in already. We need the light. 110 volts on them. Hey, that's an interesting question. What is the voltage on those capacitors? Okay, it's humming. Doing something. Okay, now we want to read the B minus across the capacitors. Volts DC. So we're going to negative, this gigantic overused terminal. This guy, 65 volts. This guy, 88 volts. And this last guy, 105 big volts there. This one here, yeah, I think that's correct. I think that's correct. I hope that's correct. The reason I hesitated was I thought, well, wasn't these a bypass? No. There is no bypass. Cathode resistor bypass. There is none. It's 3 filter capacitors. Good show. Okay, we got this one done. Now we're going to go after the capacitor that's the grid blocking capacitor. So first, which tube is the output tube in here? This is a 35Z3. This is the rectifier. This must be the output tube here. In a different socket, 35L6. In the socket, it really doesn't go in very tight. So that's the output tube. So we're looking for a capacitor that ties onto one of the terminals of that tube. I don't see any, for crying out loud. Okay, we gotta find out which terminal it is. I'm gonna hunt down the capacitor here. Okay, after thinking that through, I think the smart thing to do is stick a 50L6 in there. If the radio works well, then maybe 50L6 is what should stay in there. Here's one right here. 50L6, number 6. Probably should test this. Yeah, I should probably test this too. Okay, let's give the 50L6 a go. Now, it's in my registered collection, so it has been tested. It's tube number 6. So it's actually listed, but I haven't checked the listing. 50L6. Okay, and we'll set this. I've already got it dialed up. 50L6. 50 on the heater. J R. That's the heater selection. 5347. 5347 0. 30 and 90. 30 and 90. Press B4. Okay, we double check. 50L6. 5347. 53470. Okay, good. Put it in the socket. See if it's good. Very great. The weather here has turned cold again. Today's high is 7 degrees. And even now it's, what time is it here? It's 10 o'clock in the morning. There's still ice on my deck outside that formed overnight. Okay, any shorts? No, flashing light is good. P4, and this one, reject point is 4100. So 4100, we gotta go up on the next scale here. 4100 would be way up here. So it's gotta get past my finger. She's a thumbs up guy. Okay, so this is a good 50L6. We'll put it in the radio, and we'll suffer the consequences. No, there shouldn't be any consequences. The consequence is putting a 35 in there. That's going to increase the overall current flow through all the tube heaters. So they're all going to be running high, running hot. That's just going to wear everything out that much quicker. But we'll see. Maybe I'm speaking too soon. Maybe somebody did something to this radio to enable it to run with a 35. And then what would happen if I put a 50 in? Everything will run low. So it's not a it's not a dangerous sort of thing. What is this laying on? It's laying right on the tube. We don't want that. We don't want that. There we are. Okay, we should test the radio again and see what happens. And this time I should put a light in. Maybe with the light out. No, that wouldn't work, would it? So let me just take a peek at the schematic here, and we'll see if it names the light. So it's a part number 45. Okay, I got to sort this out a little bit. So I found this table on the Philco radio site, and it shows all the Philco part numbers here, and then the related typical or more common part number here. So the part number that I'm looking for is 342068, and it turns out, yeah, it's a 47. No surprise, it's an extremely common light, 150 milliamp light, a number 47. I'm sure I've got some here somewhere. I don't have a lot of those. I keep using them up. So it turns out I have no 47s anywhere. I have many light bulbs, no 47s. So, but I did find a suitable replacement, 51. Draw a little more current, whoops, but will still work. It's a bit of a smaller bulb on the top, and there's no problem in here. So just when you're looking at bulbs, you know, the bigger the glass bulb, the hotter the light. That's why the bulb is bigger, and the more current it's drawing. So this guy draws about 2/10 of an amp, and this guy draws a little under half an amp. There's quite a difference between the two bulbs. So you do need to be careful. And I came across this one. It's not colored white. This is one, I'm pretty sure what this means is the glass has broken, or it's leaked air somehow inside and it's turned white. I think that's what that means. So here we are. So I'm putting this guy in. Uh-oh. Okay. Well, it's in there. It's something anyway, and it does play a role with the setting of the heater voltages, which is what we're concerned about. Now this would allow, so I'm paralleling the resistor. going to allow more voltage into the radio. At the same time, I'm demanding more voltage in a sense because I put a 50L6 in there. Huh. I don't know. Do you think somebody took the light bulb out thinking it would compensate for the 35 volt too? I don't know about that. Hopefully they didn't do anything else. But we'll find out very quickly if this is going to work or not. But first I think I got to turn the antenna on down here. Okay, since my house is now a world of cats, here's my senior cat. This Shadow's about 10 years old. And hey, she's starting to get along with the little kittens. New kitten's only been here a couple days. And she's, you know what they're doing? They're signing the contract. They're making a contract between themselves. And it takes time for cats to do that. They slowly work things out. But eventually, if they reach an agreement, then it'll be Fun City for all the cats. And they're on their way to doing that. Where are you going here? Okay. She probably wants to go outside, and that's why she's come down here to get me. But she's not saying anything, so I'm going to ignore her. Okay, so we're going to play the radio. We're going to see the light come on. And, okay, first switch is off. Plug is in. Antenna's connected. Here we go. Power's on. Nothing should happen. Nothing is happening. It's very good. Okay. So I'm going to switch it like that. Switch it like that. And, oh, by the way, look. Did I see that? Radio's okay. It's okay. Here we go. The light did not come on. Did not come on at all. That's why there's not making contact in the socket, which is a little far-fetched. Or, there's more to the story here. Don't like that. Here comes the radio. So it's got that high-pitched hum, which I think will disappear as we do more capacitors. Might be humming because there's no ground associated with this radio right now. It's completely, I'll take that back. I do have a ground connection on it. What if I remove that? A little bit of noise disappears. Yeah, really.
It's time. We'll have a check for you of the morning's prices. 680 news time, 10:39.
It is. It's 10:39.
When you seem to be sending ourselves.
Okay. Not sure why the light didn't come on. Not quite sure about the hum in there. I believe that's something that will disappear as we do more capacitors, but a little worried about that, and because you know, it's nice when you're doing work and investing time and parts into something like this that it actually get better. That would be good. I'm out of time for this morning, so tomorrow we'll just carry on and I'll do that other capacitor I was talking about. Okay, well, thanks a lot for watching, and see you tomorrow.